Okay, so I've got my cable with the four, I guess, well, they're gonna be the probe tips, and there's four of them. And as I stated, I need to get these in the probe tips level and aligned in a line. So I think the first thing I'm gonna try to do is just tape them together with some electrical tape. Okay, so for a very, very sort of rough approximation, I'm going to move my sample stage over here, which I've made with a ceramic tile, figure that, and then it's set on top of a Lego block, and I'm just going to try my best to align these and get them to the same height, which is pretty tricky. That is looking pretty good. It's probably impossible for you to tell on here on the camera whether these are in line. I may put it under a microscope and take a look and see if I can align them better that way. So I found a large magnifying glass. At least I can take a look before I take this thing up to a little microscope that I have. And I can see from the magnifying glass that definitely one of the tips is not aligned correctly. So I can make a note of which one it is. Looks like it's the first one at the top. So I'm now using the microscope here, and I can clearly see the 4 points. And looking at them more closely, I'm going to magnify, focus. I can see that they're sort of pointed. They're actually not very sharp at the tip. They are basically a grooved metal tip, and then coming down, and there's actually a hollow area at the very tip. I'm going to hold the glass slide up, and I think for this we actually don't need any. And you can definitely see the edge of the glass slide. I'm going to hold the 4 tips against the slide. Maybe I'll just lay it down on the side. Okay, so I've glued my 4 probe tips together, and I've put some electrical tape around them to hold them. Okay, so the tips are going to go in through here, and then this is going to rest on top of a Lego platform. Let me show you the testing stage. So then we'll rest on there, and then I'm going to have to figure out a way to lower the tips down onto the sample. I also need to figure out how to get these secure. I'm not sure if I want to do anything really permanent right now, because I still feel that the probe tips aren't completely aligned based on, and you'll see a picture that shows that they're not perfectly aligned. But I'm going to give this a try first, just to see if I can get the general to get this working, maybe something with that I know will work. So, well, we'll give it a try. I probably will just secure this into this upper part with just some electrical tape for now. Okay. Okay, so I've put my probe head stage on to my measuring stage, and I'm realizing that there's a definite disadvantage to not being able to tilt this up. So I think I'm going to build something out of Legos, some kind of hinge that will allow me to lift up this the probe arm. I guess we could call it a probe arm. Maybe I will cut this wood so that it's thinner and then attach a hinge here. I'm not really sure right now because we need some way to attach this and then secure it to our to the base. So I think something that will allow this to swivel, and then maybe just a regular hinge attached here to another piece of wood would be sufficient, and then maybe I can clamp that piece of wood down to the ceramic tile. That's what I'm thinking right now. Design number 2. So instead of the wider stage, I have decided to put this onto a hinge stage. So here's now it's the probe arm, which will swing down. It's on a hinge. I moved the opening, the place where the probe tips are going into. I moved it to the end because I saw that where it was before is probably not going to get good contact with the surface. Now the only thing I've noticed now is that this channel right here is no longer going to be bringing the probe tips down at a right angle to the sample. So I may have to cut another channel which is perpendicular to the sample, or just widen out this hole so that I can get the tips into a perpendicular position. Yep, so now I'll probably just use some Legos to secure it to the stage, and maybe over here on the side I'll build just kind of a box and put a few Legos over the top to hold it in place, and then I'll put the probe tips in here, see if these fit okay. These seem to work in that space, and so that'll be the next step to get that secured. So I want to demonstrate the operation of the 4-point probe, the newly designed Lego arm, which goes up and down on a hinge. Here we have the battery for the current source, the resistor to limit the current, and I'll just show this in operation with the graphite square that I'm using, which so far is the only material that is giving me, well, let's just say results that may actually be real, or at least physically interpretable. Great, and I'm going to set up the multimeter so that you can see it right here. Okay, and then we have let's set this to voltage over here. Okay, so you can see here right now the probe arm is down. We're going to attach the probe tips to the arm. So first I'm going to lift this up. I'm going to put my graphite square sample. It's not exactly the right geometry, which is a problem. And then basically I can open the clamp here and I can put the probe tips in, and I just try my best to first get really good contact between the probe tips and then I clamp this down with the clamp's handle. And then we're going to measure a couple places. For weight, I've been just using a 300-gram weight for now. So I can take first we're going to measure across the resistor to see how much current is going across there. And so at this point, often, you just need to make sure you're in the right setting. But often I just have to lift this thing up, and I'm going to have to just press into the middle of the sample with my hand. So you can see here, it's across the resistor, we're getting about 0.1314 volts right there. Okay, so try to keep this in the same configuration. Get my probe tips back on. And then I'm going to switch this over here to the other end of the battery, which will be testing the voltage between the two outer probe tips. So we should be getting a voltage drop there. So yep, we're getting about 8.49 volts across the outer tips. Oh, 8.56. And so you can see that this instrument is highly contact dependent. Getting the 4 probes into the right configuration is really important. All right, so now I'm going to remove these 2 clips. I'm moving to the middle 2 probe tips, and I'm seeing how much voltage. I'm measuring the voltage between the inner 2 probes. The outer 2 probes are producing current through the sample as we tested with the voltage that we got, and between the inner 2 probes we're getting about 1.47-ish, 1.5-ish volts across. It's possible, and certainly with better contact we may get a more accurate number. The sample is not completely a square. I need to recut a square that's 11 by 11, which is the size of the tile there, and it's also a size which is 40 times the spacing between the probe tips, and that will allow us to avoid any correction factors that we need based on the geometry of the sample, because the sheet resistance, if, as we saw with the 2-point probe, if it's in a square configuration, then we're measuring the ohm square for the sample, and so there's no correction necessary for the geometry. So we're getting a pretty steady voltage there right now, about 1.43, 1.42. So then I just enter these into a spreadsheet, these values into a spreadsheet, and then I use it to calculate my sheet resistance, and then also my resistivity based on thickness, if I know it. For the graphite sheet, I don't know it. So instead, what I do is I back out a thickness based on the literature value for graphite, um, and then see if that thickness is reasonable for the sample. I also estimate a sheet resistance that I should be expecting, based on if I have a known thickness, then I can calculate the sheet resistance that I should expect based on the literature resistivity. Okay,